Okay guys, so welcome back. I just wanted to talk to you today about inconsistent and dependent systems of equations, and this goes in line with matrices. And so our notes first start off with a system of equations is considered inconsistent if it has no solution. So we need to identify what that means in terms of what a matrix is going to look like. So if you do your Gauss-Jordan elimination, which was the last section we talked about, let's say we're doing this one 1 0 0 2 0 1 0 3, and let me erase that real quick, and let's say you get the following 0 0 0 2. Okay, and I don't want this to be that. I'll just put 0 there. Okay, so we have the following matrix. Now let's read off the solutions to this. This first one says 1x 0y plus 0z is equal to 2. So this means x is equal to 2. The next one is 0x plus 1y plus 0z is equal to 3. Okay, so that means y is equal to 3. And the last one says 0x plus 0y plus 0z is equal to 2. But this is all 0. 0 is equal to 2 is what that says. That's not good. So this means no solution. Inconsistent. Okay, so what you really look for is if you get something that resembles that, that tells you that it's inconsistent and that there's no solution for that system of equations. Because it's ultimately telling you that 0 is equal to 2, or 0 is, it could put anything here. I could end up with -2 there. I could end up with infinity there. I could not infinity. I could end up with 900,000 there. I could end up with any number there. But as long as this is all zeros, this will be inconsistent. Okay, so let's keep going. A system is considered to be linearly dependent if one of the rows is a linear combination of the other. The difference between no solution and infinitely many, or a linear dependency. Let's take the same matrix. We had 1 0 0 2. We had 0 1 0 3 and 0 0 0 0 this time. Now this is the indicator that these are linearly dependent, so it means that this third row was a multiple of two of the other rows. So I don't know what the combination was, the linear combination was, but it could be, I don't know, 2 times row 1 added to row 2, or plus row 2 is equal to row 3 or something like that. And when that happens, you get a row that cancels out. Another example would be as if I had x plus y is equal to 2, and then I had 2x plus 2y is equal to 4. Notice that this is just 2. If you multiply the top row by 2, you get this row. That would mean that these are linearly independent. So watch what happens. If I do 1 1 2, and then I do 2 2 4, and I do -2 times row 1 added to row 2 yields row 2, because we're doing Gauss-Jordan, then what I get is 1 1 2. -2 times 1 is -2, added to this 2 is 0. -2 times 1 is -2, added to this 2 is 0. -2 times 2 is 4, -4, -4 plus 4 is 0. So what does this say? This says that you have x plus y is equal to 2. That's the original top equation. So in this case, if you want to get any solutions for this, then all we need to do, let's say y is equal to t. Okay, that means that we've chosen y to be our free variable. Then we can write x in terms of t. X plus t is equal to 2. We subtract t. Oops, that's not t. Then we have x is equal to 2 minus t. And so our solutions, or our solution, will be t2 minus t and t. So what does this mean? This means that if I pick t as 1, let t equal 1, then we have 1, 2 minus 1 is 1, so 1, 1 is the solution. If you plug 1, 1 into that, oh look, 1 plus 1 is 2, 2 plus 2 is 4. Let's say let t equal 2, then our solution here is going to be 2, comma, 2 minus 2 is 0. So if we do that one, we plug 0 into this one, 0, 2. So 0 into x is 0, plus 2 is 2, so that worked. 0 into this is 0, 2 into that is 4, so that worked. So you can see we're getting more than one solution. In fact, we're getting infinitely many solutions. No matter what you pick for t, this is always going to work. And so what we've done is we've created a dependent system. It depends on what one of the variables is. You could have said x is t and then solve for y, and it would have been it would have given you the same results that you're seeing now. And so I hope that helps you see that there are infinitely many solutions to these, and that's what makes these dependent. They're dependent on what you pick for y. Okay, a system with more variables than equations. I believe a system with more variables than equations. So for instance, let's say we do x plus z is equal to 4, 2x plus y plus 2z is equal to 8. I don't know the solution to this, but this is 3 variables, 2 equations. These will always be dependent systems. And so what we have is 1, 1, 1, 4, 2, 1, 2, 8. And if we solve the system, we're going to do -2 times row 1, add it to row 2, yields row 2. And the reason I'm doing that is I want this to be a 0 down here. Okay. So we have 1, 1, 1, 4. And then we have -2 times 1. So let me write that row. It's going to be -2, -2, -2, -8. So we're going to add those as we please. So this is going to be -2 plus this is 0. -2 plus 1 is -1. -2 plus 2 is 0. And -8 plus 8 is 0. And then we can just change. We're going to do -1 times row 2. And we have 1, 1, 1, 4. Then we have 0, 1, 0, 0. Okay, now let's take these equations. We have x plus y plus z is equal to 4. And then we have y is equal to 0. Okay, so they've given us y is equal to 0. So now let's come up with a solution to this. So we know y has to equal 0. That's given to us. Because if y is anything other than 0, this will not have a solution because this bottom line is telling us y is 0. But now we have x plus y plus z is equal to 4. Well, we know y is 0, so we can get rid of it. So if x plus z is equal to 4, choose let z equal to t. Okay, so that's our solution, t. Then x plus t. Let me make this a little bit more linear to follow. Then x plus t is equal to 4. And x is equal to 4 minus t. Okay, and so anything that is of this form, you pick a value for t, and then you get what x is, that will be a solution to this system. And so you can see these are dependent. I think it's always the case that they're dependent if you have more variables than equations. Okay, guys? So I'm going to end this video here, and then I will pick up on the next video where we left off. Thank you, guys.